So glomerular filtration rate is the volume that is filtered by the kidneys in 1 minute. So that first step of the nephron, where we go from blood to filtrate, that's what we're talking about. This is typically about 120 to 125 milliliters per minute. So quite a bit of volume each minute that your kidneys are going to turn into filtrate. And then again, most of this is going to be reabsorbed. But we're not talking about that yet. GFR is proportional to the net filtration pressure, the surface area that we have for filtration. So this is all the nephrons of both kidneys, and then the permeability of that membrane, the filtration membrane itself. Well, which one of these is going to be able to be regulated? It's going to be net filtration pressure. And specifically, what component of net filtration pressure can we dynamically regulate in our bodies? Let's look at net filtration pressure again. Here are the components, and hydrostatic pressure in the glomerular capillaries, that's blood pressure, right? That's dependent on blood pressure. That's where changes to NFP and therefore GFR are going to occur. So we're going to regulate GFR by regulating hydrostatic pressure in the glomerular capillaries, by regulating blood pressure. However, we can either regulate blood pressure of the entire body, so central blood pressure, mean arterial blood pressure, or we can regulate blood pressure locally, GFR locally. So here's those two types. Another name for this, so these are also called autoregulation. So regulation within the kidneys themselves, local, and extrinsic is central regulation. So this is going to be central nervous system and endocrine system. This is other name. So I already mentioned one way this can happen is by central. The goal of this, so let's do the goal, is to maintain mean arterial blood pressure. That's the goal of long-term central regulation. This is going to affect GFR as well. Another goal of this regulation of GFR is to maintain GFR. That seems pretty obvious. And despite changes in systemic blood pressure. So we're going to have local changes that can regulate this rate locally, independent of the central nervous system. We're also going to have regulation from above, from the central nervous system, endocrine system, that is going to affect GFR by maintaining blood pressure systemically. Sometimes these will be in conflict with each other. Last thing I'm going to do for this video here are just the types, the names for these. So these ones should be easy, actually. Hormonal, endocrine system, and nervous. We had a type for autoregulation when we talked about blood vessels. We talked about a way that blood vessels can dilate and constrict just based on local pressure, so stretch versus lack of stretch. This was called myogenic, a property of the smooth muscle itself to maintain pressure despite, maintain perfusion despite changes in pressure. We'll come back to it. The other one is going to be tubuloglomerular. Mechanism or feedback. So I'll start off by talking about these two and then tell you why we would need to override those to go to extrinsic regulation.